Hey everyone, and welcome to The Explainer. Today, we're going to tackle two ideas that sound super complicated, but are actually surprisingly simple. We're talking about permutations and combinations. Trust me, by the end of this, you'll see them everywhere. Let's jump right in. Okay, so let's start with a puzzle. Picture this. You're a bank manager. You've got 5 amazing employees and 2 very different open spots. Let's say one's a teller, the other's a loan officer. You decide, hey, let's try everyone in every possible pairing for a month to see what works best. The question is, how many months would that actually take? This is the kind of problem where you realize you need a system. I mean, you could try to just scribble them down, right? Okay, Bob as teller, Susan as officer, then Susan as teller, Bob as officer. But you'd get lost so fast. It's a total headache, and you're almost guaranteed to miss one or count another one twice. This is exactly why we have these cool mathematical tools to make it easy. So here's our roadmap for today. First, we'll dive into permutations, which is all about when order is absolutely everything. Then we'll look at combinations for when order, well, doesn't matter at all. After that, we'll put them side by side in a little showdown so you'll never mix them up again. And finally, we'll come back and solve our bank manager's problem and see how this stuff pops up all over the place in real life. All right, let's get into it. First up to bat is the permutation. This is your go-to tool for any situation where the sequence, the arrangement, the order of things is critical. So, the textbook definition says we're paying due regard to the order. That's really just a fancy way of saying that the order matters a lot. It's not just about what you pick, it's about the specific spots they're in. And listen, if you only remember one thing from this section, make it this little trick. Permutation starts with a P, and in permutations, the position of every single item is what counts. So just think, P is for position. Simple as that. Okay, let's get a visual. Imagine a photographer trying to line up 3 guys for a picture. We've got Suresh, Ramesh, and Mahesh. They're just standing in a row. How many different photos can the photographer take just by shuffling their order? And here are the possibilities. As you can see, there are 6 of them. Each one of these is a unique permutation. Why? Because even though it's the same 3 guys, having Suresh on the left and Mahesh on the right is a totally different photo than the other way around. The positions change, so the arrangement changes. So, how in the world did we get to the number 6 without having to write all of that out? Well, this is where the math is actually fun. Just think about it logically. For that first spot on the left, how many choices do we have? 3, right? Okay, once we've placed one person, how many are left for the middle spot? Only 2. And for that last spot on the right? Well, there's only one person left. And all you have to do is multiply those choices together. 3 times 2 times 1 equals 6. Boom. And this specific type of calculation, where you multiply a number all the way down to 1, has a cool name. It's called a factorial. So in math language, you just write this as 3 with an exclamation mark after it. It's a neat little shortcut. Okay, so we've established that order is king for permutations. But what if we just throw that rule out the window? What happens when order doesn't matter at all? Well, that brings us to our second big idea, combinations. A combination is all about the selection, not the arrangement. You're just picking a group of things. It's like throwing items into a bag. The order you threw them in makes absolutely no difference. They're all just in the bag together. And of course, we've got a memory trick for this one too. Combination starts with a C, and you can think of it as forming a committee or making a choice, right? If you're chosen for a committee, who cares if you were picked first or last? You're still on the committee. This quote right here, it really nails the difference. As a permutation, an arrangement, AB is totally separate from BA. But as a combination, as a group, they are exactly the same thing. It's the group of A and B. That's it. So let's go back to our 3 friends, Suresh, Ramesh, and Mahesh. We know there were 6 different ways to arrange them for a photo, 6 permutations. But how many different committees of 3 can we make from them? Just 1. It's the same group of 3 guys, no matter how they're standing. All 6 of those different photo arrangements collapse into one single combination. Okay, we've met the contenders. We have permutations, where order is everything, and combinations, where it's nothing. Now for the most important part, figuring out which one to use and when.
It is time for the P versus C showdown.
So how do you decide? Honestly, it all comes down to asking yourself one single powerful question. Before you touch a calculator or a formula, just stop and ask, for what I'm doing right now, does the order actually matter? The answer, yes or no, will instantly tell you if you're in permutation land or combination land. It's the golden key. And this little table breaks it all down. Think about a permutation as arranging something, like a schedule or giving out prizes in a race. First, second, and third place are very different things, right? The order is crucial. Now think about a combination as just selecting a group, like picking 3 people for a project team. The people you pick matter, but the order you announce their names in, totally irrelevant. Okay, this is all great in theory, but let's make it useful. Why does knowing this difference actually matter? Well, let's go all the way back to that bank manager we started with and finally solve her problem. All right, we're back at the bank, 5 employees, 2 different positions. So what's that one question we have to ask ourselves? Come on, you know it. Does the order matter? Yes, 100% yes, it matters. Being the head of loans is not the same thing as being the head of customer relations. So putting employee A in loans and employee B in relations is a completely different business outcome than putting employee B in loans and employee A in relations. Since the order creates a different result, we know it's a permutation problem. And how do we get to 20? It's easy. For that first open position, the manager has 5 employees to choose from. Once that spot is filled, she has 4 employees left for the second position. So we just multiply them. 5 times 4 equals 20. That's it. There are 20 different arrangements to test. If each one lasts a month, that's 20 months, almost 2 years before a decision has to be made. And once you start looking for this, you see it everywhere. A poker hand, that's a combination. It doesn't matter what order the dealer gave you the cards. But your Amazon delivery route, that's a permutation. The order definitely matters for efficiency. And your password, that's the ultimate permutation. PASS is very, very different from SSAP.
So the next time you're faced with a choice or have to arrange something, just take a second. Ask yourself that question. Are you just forming a group, or is the specific sequence the whole point? Now you've got the tools to know the difference.